Hello everyone, welcome back to practical sessions on embedded system course. So today we are going to study practical number 7. The title of this practical is development and execution of program in a C to generate PWM waveform. So PWM in the sense that is pulse width modulation waveform. So by using this PWM waveform, we can control the speed of DC motor. Okay, so such PWM waveform with varying duty cycle, we can control the power being fed to the DC motor. Okay, so the speed of DC motor, it depends on three factors. One is load, that is the shaft of DC motor is connected to a particular load. So as load increases, speed decreases. So the speed of DC motor depends on load. Then it depends on what is the voltage being fed to motor, that is voltage, and what is current flowing through the winding of this motor. Okay, so on these three factors, the speed of DC motor is depend. Now if the load is fixed, and that is normally fixed, okay, in any embedded system, if you are employing DC motor to rotate some object, okay, then load is fixed. Okay, then the speed of DC motor you can control by controlling voltage or current being fed to the DC motor. Okay, and voltage and current, that means that is power. We can control power being fed to the DC motor. Okay, so to control the speed of DC motor if the load is fixed. Okay, so by using PWM waveform you can control, okay, power being fed to the DC motor. So by controlling the duty cycle of PWM waveform, that is T on period. So what is PWM waveform? Basically it is a square wave waveform. Time period is fixed, and its pulse, that is T on period. So in square wave there is T on and T off. Okay, so T on will be equal to T off in perfect square wave. So that T on period, we can vary by keeping the time period of that waveform. Okay, so by varying that T on period we can vary the power being delivered to the motor. Okay, so in this way we can achieve control of DC motor. Okay, that is speed control of DC motor. Okay, so for that purpose we can employ such PWM waveform to control the speed of DC motor. Okay, so we are going to generate such PWM waveform to control the speed of DC motor, that is interfaced with 8051 microcontroller. So for this we are going to study this program. So the title of this program is Write a 8051C program to generate a PWM waveform on pin 0 of port 1. So on pin number 0 of port 1, we are going to generate such PWM waveform with varying duty cycle. So assume two switches SW1 and SW2 are connected to pins 0 and 1 of port 0. Okay, so to these two pins, two switches are connected, and your program will monitor the status of these pins and generate PWM waveforms as follows. So this is switch 2 that is connected to pin number 1 of port 0, and this is switch 1 that is connected to pin number 0 of port 0. So if these two switches are closed, okay, 0 0 means it will input 0 0 on pin 0 and pin 1 of port 0, then we have to generate uh, PWM waveform of 25% duty cycle. That is on time will be 25% of the total time period. Okay, if these switch positions are 0 1 means switch 2 is closed and switch 1 is open, then we have to generate 50% duty cycle, means it is a perfect square wave. If switch positions are 1 and 0, we have to generate 75% duty cycle PWM on pin 0 of port 1. Okay, and if these switches are 1 1 means both the switches are open, we have to generate 100% duty cycle PWM, means uh, on pin 0 of port 1 output will be always high. Okay, so that is total out of total time period, 100% for the 100% time period, that is T on period, means output will be high. Okay, that means continuously output will be high on pin 0 of port 1. That is nothing but PWM waveform with 100% duty cycle. So such different waveforms, PWM waveforms, we have to generate on pin number 0 of port 1 by monitoring the switches SW1, SW2, which are connected to pin 0 and pin 1 of port 0. So this is the task. So for this is the interfacing diagram. Okay, so this is the DC motor. So DC motor is being controlled by controlling this transistor, and this transistor is under the control of pin number 0 port 1, on which we are generating PWM waveform. Okay, so when this transistor is on, motor will be on. When this transistor is off, motor will be off. Okay, so we have studied this under DC motor interfacing. Okay, so to turn on this transistor, we can control this pin of 805, that is pin number 0 of port 1. Okay, on which we are going to generate PWM. So suppose here for 25% of time, if this transistor is on, and for remaining 75% transistor is off, that means we are feeding here PWM of 25% duty cycle. Okay, to generate that, so see here, this DC motor circuitry is isolated from 8051. Okay, by using this opto isolator ILD74. Okay, so this is for protection purpose, so that back EMF will not affect this microcontroller circuitry. Okay, so here, see here, if the output of this pin number 0 of port 1 is 0, what will happen? This internal LED of this opto isolator will conduct. Okay, because anode is connected to plus 5 volt, and if this cathode is 0, means LED will conduct, and due to that, this photo transistor will conduct, and it will turn on this transistor. Okay, means to turn on this transistor, means to turn on this motor, I have to output 0 on pin 0. Okay, and to turn off this transistor, that is to turn off this motor, okay, we have to output 1. Okay, and the time for which the output is 0 and output is 1, that will determine the frequency and duty cycle of PWM we are generating on pin number 0 1, port 1. So here two switches are connected to pin number 0 and 1 of port 0, so that are not shown here. So by monitoring these two switches, I have to generate PWM here at pin number 0 of port 1. Okay, so this is the task. So I will go to the program which I have already written. Okay, so I have opened it in Kill compiler. So this is the program. So this is the title of this experiment. This is the program statement. Okay, and this is the program. Okay, so see here, I will explain the program. So hash include reg51.h, and s bit mtr is equal to p1 caret 0 semi comma, means I'm representing pin number 0 of port 1, on which I'm generating PWM waveform as mtr. Okay, so in the remaining program, I can represent pin number 0 of port 1 as mtr. Then void ms delay unsigned int value. So I am declaring this function ms delay, which is a return to generate a delay in a millisecond of a value that we are passing to this function. Then main program, under this main program, see what we are doing. So void main void unsigned char z, z is declared as a unsigned char type of variable. Then p0, that is port 0, is assigned value 0xff. Okay, means I'm configuring on the pins of port 0 as input, because out of port 0 pins, pin 0 and 1 are connected to two switches. Okay, so these two pins should be configured as input pins. For that, I'm loading ff into port 0. Okay, that will configure all the pins of port 0 as input pins. So remaining pins of port 0 we are not using. Okay, so we are using only pin 0 and 1. Then mtr is equal to 0, means mtr is what? Pin number 0 of port 1, on which we are going to generate PWM waveform. I'm configuring that pin as 0, that is the output pin, by loading 0 um, into that bit of port 1, that is bit 0 of port 1. Okay, so next, while means continuously, infinitely, whatever statements in between this opening and closing brace. Okay, so this will repeat continuously. Now see, inside while loop. So Z is equal to P0, means I'm reading data on port 0. Okay, because I have to monitor pin 0 and pin 1 of port 0. Okay, so for that I'm taking whatever data in port 0 in Z variable, and then I am bitwise ending contents of Z with 0x03, which is nothing but 0000 and 0011. Okay, we are interested only in these two bits, that is bit 0 and bit 1 of port 0. Okay, to which two switches are connected. So I'm masking all other bits because I don't have any interest in other bits of port 0. Okay, so I'm masking so remaining bits except bit 0 and bit 1. So that I'm doing by using AND operator, ampersand. Okay, so I will get in Z, I will get either value 0, 1, 2, or 3 depending on what is switch position of switch 1 and switch 2. If both the switches are closed, so I will get value in Z 0. Okay, and all the that is switch 1 and switch 2 are open, then I will get value 3. Okay, accordingly I will get value in Z out of 0, 1, 2, and 3 depending on what are switch positions of switch 1 and switch 2. Okay, and depending on value in Z, whether it is 0, 1, 2, or 3. If it is 0, means on pin 0 and 1 of port 0, switches are inputting data 0, 0. If this Z is 0, 1, then it is inputting 0, 1. If Z is 2, it is inputting 1, 0. And if Z is 3, it is inputting 1, 1. So depending on value in Z, we are going to generate PWM waveform of a particular duty cycle. If value in Z is 0, then we are going to generate uh, PWM waveform of 25% duty cycle. If value in Z is 1, we are going to generate PWM waveform of 50% duty cycle. If value in Z is 2, then we are going to generate PWM waveform of 75% duty cycle. And if value in Z is 3, then we are going to generate PWM waveform of 100% duty cycle. Okay, now see here, for that I am using switch statement. So switch in a parenthesis Z. So value of Z will get compared with various cases here. So there are three cases and one is default. Okay, so value in Z will compared with first case value, so that is 0. If match occurs, means value in Z is 0, then whatever program that is enclosed in between this opening and closing braces, that will get executed. Okay, if value doesn't match, it will go to next case, and if match found, that is value in Z is 1, then this program that is enclosed in between opening and closing braces will be executed. If again there is no match, then it will go to next case, and if value matches, that is 2, then whatever program enclosed in between opening and closing braces here, this will be executed. And if the value in Z does not matches with all these cases, case 0, case 1, case 2, then here default, whatever program written under default, okay, that will be executed, and that is only one statement. So that is not enclosed in between opening and closing braces here. Okay, and here this case statement ends. Okay, so here suppose the value in Z is 0, so what will happen, this program will be executed, that is program in this opening and closing braces. So MTR will be 1, so we are outputting 1 on pin number 0 of port 1, that on which we are generating PWM. Okay, then calling delay of 25 millisecond, then we are making MTR 0, then calling uh, delay of 75 millisecond. Okay, and then this program is ending here. Break means it will come out of loop and go to the end of this switch statement. Okay, and again this is under switch statement is under while loop. Okay, so again we are reading port 0. Okay, that is pin 0 and 1 uh, of port 0 we are reading, and again we are making decision, okay, to generate the particular duty cycle PWM. Okay, so here suppose that switch 1 and switch 2 are closed, then it will continuously generate this, or it will continuously execute this program inside this case, and it will generate a duty cycle of 25%. It will generate PWM waveform of 25% duty cycle. Okay, because here we are making MTR 1, means pin number 0 of port 1 we are making 1, then calling delay of 25 millisecond, and we are making it 0 and again calling delay of 75 millisecond. Okay, means for 25% time the MTR pin will be 1, and for 75% time MTR pin will be 0. It will generate that is square wave of or PWM waveform of 25% duty cycle. Okay, now if that Z value in Z is 1, okay, then what should happen? So PWM waveform of 50% duty cycle should generate. For that I am outputting 1 on MTR, then calling MS delay of 50 millisecond, then outputting 0 on MTR, then calling delay of same, that is 50 millisecond. It will generate PWM waveform of 50% duty cycle. Okay, now if value in Z is 2, see here, now I'm outputting 1 on MTR and calling delay of 75 millisecond, and outputting 0 on MTR and then calling delay of 25 millisecond. So this will generate PWM waveform of 75% duty cycle. Okay, now value in Z, it could be either 0, 1, 2 or 3. Okay, so if it is 3, then whatever statements under default that will get executed. So here MTR we are making continuously 1. Okay, so this will generate duty cycle, that is a PWM waveform of duty cycle 100%, because continuously that pin number 0 of port 1 will be high. Okay, so continuously it is high means it is PWM waveform of 100% duty cycle. Okay, so in this way this program will perform, and this is MS delay as usual function. Okay, to generate a delay in milliseconds. Okay, now I will build this program, check for errors, so no errors, then I will go on debugging. Okay, okay, now see here, this is a port 0 pins, and this pin number 0 and pin number 1 are, we are assuming that are connected to two switches, switch 1 and switch 2. Okay, so now here right now 1 is being inputted on these pins. Okay, means value in Z will be 3. Now we will check. Okay, so I will use step execution. So this will configure port 0 as input and pin 0 of port 1 as output. Then I am reading port 0 data. So here what is value in Z? It is, so what is value in Z? It is 3, because these two bits are 1 1. Okay, so we are masking these all other bits, okay, using AND operator. So I will get 3 in Z. Okay, now if value in Z is 3, it will not match with this case 0, case 1 and case 2, so it will directly go to here default. Okay, so I will default, so output will be MTR will be 1. Okay, now I will run this program. So I will monitor the data on MTR pin here in the this analyzer window, logic analyzer window. Okay, now I will run the program. So continuously this MTR pin will be high. So such this waveform is nothing but PWM with 100% duty cycle. Okay, so now I will stop the program, stop, and what I will do, I will make now these two pins of port 0 as 0 0. Okay, means both the switches are closed now. Okay, so now I will again run the program. Now see the output. Okay, now see here, now I will stop. Okay, now see here, now we are getting waveform, such waveform on MTR pin, that is pin number 0 of port 1, on which we are generating PWM waveform. So total, out of total time period, for 25% duration the output is high, and for 75% duration output is low. So such waveform is called as PWM waveform of 25% duty cycle. Okay, so if switch position are 0 0, I will get such PWM with 25% duty cycle. Now if switch positions are 0 1, okay, 0 1 like this, what I should get, I should get PWM waveform of 50% duty cycle on pin number 0 of port 1, that is MTR pin. So I will now again run. Now see here, now I will stop. So I am getting now such waveform on pin MTR, that is pin number 0 of port 1. So for half of the duration output is high, and for half of the duration output is low. So this is PWM waveform with 50% duty cycle. Okay, now I will change the switch position. I will make this 1 and this I will make 0. Okay, so now I will again run, see the output. Okay, now I will stop. Now see, for the 75% duration output is high, and for the 25% duration output is low. Such waveform is called as PWM waveform with 75% duty cycle. In this way, depending on switch position that are connected to pin number 0 and pin number 1 of port 0. Okay, so this program is generating PWM waveforms with various duty cycle, that is 25%. If the switch positions are 0 0, then 50% duty cycle. If switch positions are 0 1, 75% duty cycle if the switch position is 1 0, and 100% duty cycle if the switch position is 1 1. Now see, if I make this switch position now, okay, if I make this switch position 1 1, see what happens. I will run the program. So output is continuously high. That means this is a PWM waveform with 100% duty cycle. Okay, so this is about PWM generation program. Okay, so you can check it. So only one thing I want to explain. Okay, see the interfacing. So in the interfacing, see pin number 0 of port 1 on which we are generating PWM waveform. Okay, it is controlling this transistor. Only thing is that if output is 0, then this program or this interfacing, okay, here the LED will conduct and it will turn on this photo transistor, and then it will turn on this transistor. Okay, and then motor will rotate because current will flow through this motor and go to the ground. Circuit will complete and motor will rotate. Means if we output 0 here, motor will rotate. If we output 1 here, motor will stop. Okay, so opposite logic is there. Accordingly, you have to modify the program. So instead of here outputting 1, here we have to output 0 and here 1. Similarly, here 0 and here 1. Actually, if you, according to the interfacing given, if you want to program, so opposite logic should be generated. Okay, then only the, if the switch positions are 0 0, then this motor will rotate with 25% duty cycle PWM waveform. Means for 25% of time the motor will rotate, and for remaining 75% motor will not rotate. Okay, so that is not the case. Because power is being controlled, motor will continuously rotate but with speed of 25%. Okay, so I will take my words back. So this motor will rotate with 25% speed. Okay, when the switch positions are 0 0. Okay, so that means this pin, PWM generating on this pin, okay, it will supply power to this motor, okay, only for 25% duration time out of 100%. Okay, so due to that, this motor will rotate with uh, 25% speed. If the switch positions are 0 1, then here we are generating 50% duty cycle PWM. So due to which 50% power will be delivered to this motor, and motor will rotate with 50% speed. Okay, if the switch positions are 1 0, here we are generating PWM with 75% duty cycle. Means for 75% duration out of total 100%, the power is being fed to the motor, and for remaining 25% power will not fed to the motor. Okay, so due to that, motor will rotate with 75% uh, speed. Okay, and if switch positions are 1 1 here, then output, uh, that is PWM output, will have 100% duty cycle, due to which continuously the 100% power will be fed to this motor, and motor will rotate with 100%, that is maximum speed. Okay, so in this way you can slightly modify the program and you can use with that interfacing diagram. Okay, so this is about uh, that is a speed control of DC motor using PWM waveform. Okay, so this is practical number 7. Okay, so you can write up. Okay, I will send you PDF file, but only thing is that the program in that write up is different. Okay, so that is bit complex, so you have to replace that program with this program. Okay, so in that program only one difference is there. So whatever PWM waveform we are going to generate on pin number 0 on of port 1, so in that program it is asked that to generate the frequency of 2500 hertz. Okay, so PWM frequency is given, means time period is given, so you have to generate PWM waveform of that time period. But here it is not, in this program it is not asked, you can generate PWM waveform of any frequency. Okay, so this is bit complex. So for that, here we can determine the that is a frequency with which we are generating PWM. So here total time period of PWM we are generating in this program is 100 millisecond. Okay, so from that 100 millisecond is the time period. From that you can determine the frequency. That is frequency of PWM will be 1 divided by 100 millisecond. This is the frequency of PWM that will get generated on MTR pin, that is pin number 0 of port 1. Okay, so accordingly as per requirement you can use timers, okay, to generate uh, particular PWM frequency, okay, as per your applications requirement. Okay, so this is about uh, speed control of DC motor by using PWM technique. Okay, so okay, I will stop here.